that are suitable for particulate, but that is a slightly driven design. The main idea is to trap the particles or the contaminants in a wet medium, and then they will settle in the wet medium, and they have a suitable disposal system with neutralization and prevent contaminant building in the inlet and prevent water carried over in clean water to the fan stack. Okay, this one you will see at glove factories. These are normally glove factories or electronic factories where you're using wet chemicals, chemical vapors, right? Acids, solvents, certain type of solvents, ammonia, alkalis, right? And it's suitable for hot gases and vapor. Here we have what we call absorption filters. Basically, these filters are made of activated carbon filters. We use process called adsorption. Activated carbon is a porous material that provides large surface area to absorb contaminants, suitable for laboratory activities and suitable for VOCs, volatile organic compounds. And replacement needs when the filter is saturated. The problem with this is frequent replacement may be required, all right, if your contaminant place is dusty, right? So we come to fan design. Again, the fan design, the IR will calculate all this to decide how big the fan and the motor will be required, and location and so on. A lot of calculations involved. We need to consider the usage, the type of contaminant, maybe it's for dust, what type of fan, because you need to create the correct sufficient static pressure and velocity pressure. And you should also purchase fans where it's accessible for cleaning. So fan serving systems with air cleaners or random design should be selected, right? So, and ideally, which does not really happen practical, the fan should be located 5-10 diameters from the air cleaner, but this is seldom due to location constraints. Okay, various types of design specifications to consider is static pressure losses, proper sizing, plastic methods. Then we come to stack design. Stack design, it refers to certain engineering requirements, and this would be to meet ambient air quality guidelines. So the designing IR will go into Clean Air Act Memorandum UK, guidelines on good stack height designs and air dispersion. Okay, DOE requires a minimum stack height of 3 meters above the highest structure within the vicinity of the stack. And you should have an efflux velocity, a discharge velocity. Efflux velocity is discharge velocity of the stack of between 8 to 10 meters per second, right? 1,005 to 2,000 feet per minute. And there should not be any weather caps that obstructs the free flow of gases, fumes, or dust. These are examples. The first one, DOE does not allow. Second one, DOE allow. The third one, DOE recommends that you have what? These are rain caps. And your designing IR will implement that in. Okay. A good design stack, so to make sure that it escapes the building and does not return into the building air intake and has to disperse contaminant of ambient air so that it does not cause an unacceptable situation when it reaches the ground, and to prevent settling of moisture and problems in starting of the fan. Okay. So let me answer some questions here. In terms of ducting, does round shape? Yes, round shape has less surface area. When it has less surface area, you will have less friction loss, and then you will have less friction loss. So that means you do not need that much volumetric flow rate. Okay. I'll just give you an example of on a 12 inches diameter round duct, your area is 0.785. On a 12 inches square duct, it's 1.0 area feet squared lah, right? Right. So you actually the what they call the area size for 12 inches square duct is more than a 12 inches round duct by 20%, and it will require more energy or more velocity or more flow rate to carry. So you are actually having to design more a bigger fan for the system if you're using square ducting. But why do most people, a lot of companies, use square ducting rather than round ducting? From what I understand from the industry, right, square ducting is easier and cheaper to make and easier to fix in the sense of to install. That's the only thing I can say. That's what I understand. But round ducting is actually preferred. And I would suggest that all exhaust chimney stacks be in round ducting. One of the explanations why I would prefer personally round ducting. Bear in mind, when we as Hygiene Tech Tools do testing of LAV systems, right, which I'll come to later in this section, we actually have to drill sampling holes into the ducting system. If it's a round duct, we need to have 2 holes at the sampling area, sampling point, which is 90 degrees to each other on a round duct. But if it comes to a square duct, we are actually required, okay, to drill 4 holes and do 16 transverse readings inside the ducting. So if between 2 holes and 4 holes, 4 holes may weaken the ducting if it's a small ducting. So personally, round ducts are more suitable, and actually round ducts actually saves more space and is better for the system in terms of you do not need that as much flow rate as compared to what do you call that, round duct, a square duct, sorry. Okay, we take a 10-minute break for now. If for a toilet break or a drink, and we will meet back in about at about 10:30. 10:35. Wait, sumang sa oil, oil, oil. So, okay, can we start? Okay, now we go on to the roles and responsibilities on LEV by employer, employee, suppliers, designers, and the competent person. Okay, so for LEV, there are four parties that are relevant: competent person, the employers, the designer of the LEV system, and the employees who are the operators of the process that requires the LEV system. So the role of employer, you need to identify the chemicals in the work process, right? And then the employer need to select the control measures which will protect the employees from chemicals, hazardous chemicals. And then once you have decided whether you need the engineering control system or not, you will have to engage a competent supplier or engineer to design a suitable LEV system. And you should also collect input from workers to install LEV system best suited for the work process. Okay. Employee needs to allocate resources to maintain the LEV system. You have to have enough budget to build a proper system, a manpower to ensure that the system is maintained by the end users, by the maintenance people, by competent persons to be in good working order. And the job responsibilities for each LEVs on the LEV to be differentiated between the management and the workers. Training and supervision need to be given also to employees. Where right? Placement of foods, placement of the ducting, and so on. And to ensure that the LEV system is used all the time to prevent chemical exposure to health. But sometimes when you install an LEV system, right, it's not properly used. The location of food or the work area is shifted, and then you may have a LEV system, but it's not removing chemicals away from the breathing zone of the worker. You have to take, they also have to, the employees also have to take care of the LEV system. I'll give you an example would be soldering. Soldering tends to have a lot of accumulation of dust at the hood, and dust balls are created into the hood. So they, as the employee uses it on a daily basis, 8 hours a day, they should clean the system of the hood. And if it is the ducting, then they should get their technicians to do the follow-up if it's under the technician's care. So you need to actually do regular inspection daily on the LEV. Some cases is weekly, some cases is monthly. And a preventive maintenance program should be done on the LEV system. And really, once in a while, an audit of LEV compliance. And employees should feedback if there are any anomalies on the LEV system. For the LEV supplier, designer, or installer, or the IR, they have to give you the best. The employer need to discuss their requirements with the supplier and suggest they will have to give proper technical advice and the best options on the design. Okay, they should need to know the process and the working environment to propose the best option for the employer. And they have to make sure that the LEV is installed as per design specifications, and that the commissioning of the LEV is done to meet the approved design specifications. For use regulations, this will be under Regulation 18/2, right? Then to make sure that the LEV is accessible for use, maintenance, and cleaning. And if required, the LEV should be installed with relevant instruments, pressure gauges, temperature gauge, for performance monitoring of the LEV system. This is usually required when you are also under the DOE competent person requirements for air pollution control systems. If possible, the supplier should also provide training on how to use, check, and maintain the LEV system. And they should provide the employer with the design specifications, with a user manual that explains the LEV system. In the case of bag filters and scrubber operations, DOE requires that a competent person is required in the operations where they have attend the EMAS course to ensure that the LEV system is functioning all the time, and to carry out performance monitoring on the air pollution control systems, and to establish and analyze the monitoring data, and make recommendations for improvement. Okay, for that you have to attend the EMAS course on air pollution control systems. For competent person under JAP, you will have hygiene technician. This would be hygiene technician 2, which are required to carry out the LEV testing and examination once every 12 months. And when we do the testing, we will explain it to the employer, and we will give recommendations to improve the effectiveness of the system where required. Common problems on LEV: effectiveness, standardization LEV training, and preventive maintenance. This will be where most of the current users will have issues. In most cases, common problems, you have incorporate wrong type of LEV design, right? Where the systems are not designed by IR. There are no air cleaners. No chimney is not correct. Insufficient stack height. Velocity is insufficient for the contaminant that is being used, and the hood or the duct design not able to capture or transport air contaminants. This is quite common in systems where you have an old system and you modify it to use in a new process. Okay. And if you look at the two photographs here, where you have a canopy capture hood on top here, and then it is looks like the process is not proper because they're not using it in a correct way, and the canopy hood is too high up. In the bottom picture, you will notice that the ducting is quite wrongly what they call connected, in the sense that it's all connected at right angles, 90-degree angles, not 30 degrees, and a lot of bends. It may cause what they call the top ducting to have better velocity, but the bottom ducting to have lower velocity because of the problem where you have more than 45 degrees angle or branch duct entry, too close to fan, inaccessible for servicing, where accessibility is a safety issue. There's no inspection panel for duct and fan, where the hood is too far away from the source of contaminant. Common factors that cause LEV to be not effective in protecting workers. LEV is not used properly. They place the movable hoods too far from the emission point. Okay. LEV not suitable. They modify it. They add additional hoods or ducts to existing LEV, which weakens the flow rate of the system. Okay. Like in this picture, there's a possibility that the worker is conducting the operations too far away from the hood, so you will not be able to capture the contaminant. There's no ownership of the LEV system. The end user, by maintenance, or by safety personnel. The LEV is not properly maintained. No preventive maintenance. No regular inspection, servicing, or testing. Some cases that I've done, they only do maintenance just before the LEV testing by the hygiene technician when they call us to do it, right? So in these pictures, you have examples where they don't do regular inspection, and you have broken ductings, here they're using a aluminum ducting and it's torn, it's never replaced. Connection, metal ducting, they never fix it back. Holes in the ducting. So regular inspection is required for this. Accessibility issues. And here an example, okay, on this picture on the top right hand side, you'll find that when we did LEV testing, on this are the amount of what they call rubbish, okay, plastics, wrappers, paper, and so on, that gets trapped inside the ducting system and never removed, which leads to the reduction in the duct velocity. And that's where your regular inspection comes in. Same thing here at the bottom left, where you have a hood with a metal grill in front, and if you do not clean this regularly, the air intake will be low. Again, blockages, the suction is, the plastic bags are being sucked into the system, and we actually, during the testing time, remove the ducting to check why the velocity was low, and we saw plastic bags sucked into the system and had to remove them. So regular inspections are required to ensure this is not repeated. In this case, these are for systems where the airflow is very high, that is, the plastic bags can be sucked in. So once an LEV system needs to be installed at a workplace, there are a number of steps that need to be undertaken to ensure ongoing effectiveness and optimization of the LEV system. Commissioning of LEV, training on operations of LEV, preventive maintenance of LEV, evaluation of the LEV by a hygiene tech, and record keeping. I've got a question in LEV by Amirul Ahmad. LEV need to be under 1 PIC. It all depends on your, company, right? In most cases, big companies, you have facilities department. Facilities department take care, in a simple way of explanation, take care of what is above the ceiling. The production technician takes care of what is below the ceiling, which means in the production area. So it will be 2 different PICs already. And so when it comes to inspection of the LEV, each section or each department will have their own responsibilities. Example, the end user finds that there's a system is not good, the suction is not good, maybe due to blockages or ducting being blocked or ducting damage or leakage. They are the end users. They notice that the contaminant is, the airflow is not good. They need to inform somebody. And who is that somebody that they need to report to? Facilities or production technicians. So all depends on the chain of command in the company. In larger companies, you would normally, the end user would report to the production technician. Production technician comes in, see what's going on, see whether they can settle. If they can't settle it, they believe it is above this problem that is more like above the ceiling, they will then inform facility side because they are in charge of anything above the ceiling. All again depends. But if yours is a small company where one person does everything, then it all depends. So it does not need to be under one person in charge. It depends on your company organization. Second question by Juan, if internal staff at HJ2, can he do LEV monitoring monthly and yearly to comply? Okay. The regulations does not specify you must use an outside consultant, right? For the monthly inspection, it's not required to be done by a hygiene technician too. It's supposed to be done by an employee. You can download the guidelines on the LEV system by JKAP. There is a guideline on what to inspect. Basically, it's a visual inspection, right? And I will have something on this later in the slides later. The yearly inspection is supposed to be done by Hygiene Tech 2. You can do internally, okay? Bias or not is up to the Hygiene Tech 2, okay? If the system is not effective, as a competent person, he should write down in the report it's not effective, and then what he needs, what he needs to improve it with. It's up. I cannot say anything on that because the law says to be inspected by Hygiene Tech 2. Some companies do have internal Hygiene Tech 2s. They do their own LEV testing. It is good that you have an own Hygiene Tech 2 if your company is big enough, all right, that you're able to understand the system and maintain the system at its top level. Okay, I hope that answers your question. So, number of something, commissioning, training, okay, record keeping. Okay, when you do commissioning, all right, this is under Regulation 18.2 of the use regulation, basically to ensure the LEV meets the design specifications and to have the baseline data for the LEV system. It means commissioning test is done when the system is brand new, and to prove that it's working correctly according to design specifications and capable of providing protection to workers. So it complies with Regulation 18.1 and 18.2 that the new LEV should be tested by a registered professional engineer. So the commissioning LEV test results is used as a benchmark against future performance, and subsequent hygiene technicians doing testing will do this comparison, and all these records should be kept until the system is removed or upgraded. And employees should be trained on LEV systems, on the purpose of LEV, how to use the LEV, how to check the system is operating correctly, what are the limitations, and how to carry out work activities to ensure effective and optimization controls of convenience, and to know the preventive maintenance of the LEV system. And part of this goes under chemical safe handling. Another question from one, if from Dodge point of view, is it considered bias? There's no bias. You are allowed to use an internal Hygiene Tech 2 for the report. Again, like I said, it is on the Hygiene Tech 2 to provide a report. A correct report. All right. If he is professional in his work, he will do a correct report. But if he's also in charge of maintaining and the system, all right, the internal Hygiene Tech 2, your system should be pretty good, because he should know since you are internal Hygiene Tech 2, your systems should be well maintained, right? That's my point of view. So I don't think Dodge will consider it bias unless they review a report and they do actual testing on the comparison testing on the report and find that part of it fails, while you have the internal hygiene tech 2 has passed the report. All depends on the report that was done, right? Aisha Bohan, the storing chemicals in a fume hood affects effectiveness. Not really, all right? You have chemicals in use, but you are not storing bulk unused chemicals in the fume hood, are you? All right? You are storing open containers, okay? And that is the purpose of the fume hood. You're not storing bulk chemicals inside, okay? These chemicals that you store inside a fume hood is being used on a daily basis, but where the chemicals are stored in the fume hood because they're being used on a daily basis, they should be properly placed in containers with caps on, closed, and so on, and not in open, exposed. Okay, that means you don't put it in the pan and just let the chemicals evaporate just like that, right? So is that what you mean by storage? And in most cases, by right, you should have a chemical store cabinet to store your unused chemicals. Because if you store too many containers in the fume hood, you actually disrupting the flow of the fume hood itself. Okay. Where example, if you have a fume hood with baffle boards, all right, or the sides are in the center, and you're going to place one row of bottles blocking the what do you call that? The bottom part of the area where bottom part of the fume hood where the baffle boards are, where you're blocking the flow. So effectively, the flow at the bottom of the fume hood will not be getting the flow. So storage, how you store, how much you store, the number of bottles, containers is also a question. Do not store too much unused chemicals inside the fume hood. Training. There should be refresher training given to employees on the use of LEV, updates to the control of LEV, and there should be training every 2 years. New employees should be aware and understand the purpose of the LEV, and to ensure employee transfer the work process awareness of the LEV and the controls. So basically, effectiveness of the LEV, you need to know the air contaminant type and concentration. And from there, where's the source, the speed, the direction, what are the work process requirements, whether you need the amount of enclosure, capture, you decide how to match the hood to the way the work is carried out, and then the type and the size and the airflow required for the hoods. So you have various types of hoods suitable for various types of activity, right? So again, all depends on the contaminant, on where the worker is, how the worker uses, whether you need a movable hood or not, whether you need the enclosure, receiving hood, closing hood, or total enclosure hood. Basically, a lot of factors when it comes to design of the system. Right? So at the bottom part, you need to adjust accordingly. All right. Here you have the hood, right? And in this first picture, the worker is if you have the effective capture zone, say, I'm just say is at the yellow dotted line here, but he's working at the green dotted line. So it is not suitable as even if the velocity, phase velocity is good and the capture velocity is good at the yellow line, but because of the placement of where he's working, where the disbursement of the contaminant is too far away, then he won't be able to capture the contaminants. So he needs to move it nearer. So you got to either adjust the hood to a nearer position, or he has to move his working area nearer towards the hood. Right? This is a very common problem in most LEV systems, where the work is usually the worker does not move the hood if it's a movable hood, or does not work close enough to the hood for effective capture of the contaminant. Let me answer some questions first. 2 years training of LEV is compulsory by law. No, there's no section in the use regulations that requires training, but we realize that there's actually a general training thing that says in the use regulations every 2 years. So we do suggest that you have 2 years training for LEV, or incorporate a training relevant to LEV every 2 years. Because you have workers that always change, and as far as my experience is concerned, nobody trains. No company actually trains about the LEV system, right? I am thinking of coming out with a training program that is more applicable to end users on the usage of LEV system, inspection, testing, monthly inspection, and so on. But that will come at a later stage. How long is the retention period of the LEV maintenance record? We will have to refer back to the regulations. Under use regulations for LEV systems. Give me a moment. For record keeping for LEV, all right, under Regulation 19, use regulations, records of design, construction, testing, inspection, examination, and maintenance of engineering control equipment shall be maintained by employer and produced for inspection when directed by Director General. Regulation. This is Regulation 19. Retention of records by employer. Where an employer ceases to carry on business and another person succeeds him, the employer ceasing business shall hand over, and the successor employer shall retain records to be maintained under Regulations 1319. So this is Regulation 19. So based on these two regulations, for as long as the system is there, that's how long you need to keep the LEV records. Anything regarding the design, and the what do you call that? the design and so on. So if the system has been there for 10 years, keep it for 10 years. But technically, I do not think JKP will actually check it for 10 years, right? So you have to refer back to the regulations. It's not clearly stated, but here they just say pass on records. They did not. Hang on. Yes, they say maintenance. So for as long as the system is there, right? That answers your question on the keeping of the records. Okay, back to here. Optimization liquid. Okay. Okay. This is an example of a push pull system. A pull system. Okay. Where if you have a tank, a dipping tank that's too big, and you have just one capture extraction hood on the left-hand side, right? It may not be sufficient, and you will be getting chemicals coming out from the right-hand side here because of the white source of emission. So in terms of design, you may want to consider a push-pull system where the system may have an air inlet to push the contaminants towards the extraction hood, right? And this will improve the capture of the dispersed contaminants. So we call it a push-pull tank system. So various hood design effectiveness, right? We need to enclose the operation as much as possible, locate the hood as close to the emission source as possible, make sure there's enough velocity, sufficient velocity to capture contaminant, protect from cross draft, even airflow in the hoods, and provide flanges and baffles wherever possible to eliminate airflow from contaminant-free zones. Okay. So you'll find that if you just have a plain opening, this is how the air goes in. But if you have a flange added on, the blue sides, you'll find that the capture of the hood is better and the airflow is better. And again, if you design it in such a way from the hood connection that you have a plenum, and the plenum narrows into a smaller 5, example here, in this case, we have a 5-inch opening. It actually what captures the contaminant better. Again, all depends on how the contaminant, the dispersion of the contaminant is being generated. Okay, so design of the hood is also quite important. You may need high flow rate for the top one, a lower flow rate for the center one, and a very low rate for the bottom one. All depends. So your designer, when you build a new system, your designer will consider all the requirements. That's why they will also need to know your processes. You need to do preventive maintenance on your LEV system. You need to conduct a form of some sort of performance monitoring on the system, inspect the condition of the system, periodic cleanup of the system, and testing by a competent person. And if you establish a preventive maintenance program, you're able to see any weakness in the system and to ensure smooth operation of the system. So preventive maintenance is important. Again, during my course of my testing of LEV systems, there's insufficient preventive maintenance. Here there are some samples of hoods with additional covers. Effective LEV should be able to protect workers from hazardous chemicals to provide worker comfort during working, to prevent air pollution to the environment. Okay, so you have various photographs here, and some with LEV, some without LEV. So if you have the LEV, it will remove the contaminant from the work area. Here you have an LEV system. You see the ducting on the side. You see every system, you see the ducting on the side. If it's placed wrongly, it won't capture the contaminant. But if it's designed properly, right, the hood, it will capture it properly, capture the contaminant properly. So you have to optimize the effectiveness of the LEV. Sometimes you have a very strong velocity or strong capture velocity at the hood, but if you place the hood in a wrong location, it's not considered effective. So placement is also important. So appropriate design is not only effective to control the air contaminant, but it's safer to carry out inspection. It will minimize cool air losses in air-conditioned areas, more cost-effective, more energy saving, and optimize material consumption during the work processes, right? And when you build an LED system, okay, you should have safe access for workers to carry out testing, preventive maintenance, and repairing work. Here are examples of the fan and dust collectors where there are suitable platforms and ladder access for workers or consultants to go in for testing. For testing and repair works, safety needs to be highlighted here. So the other examples of safe access to carry out testing and preventive maintenance repair works. Performance monitoring and measurement of LEV. All right. Why must we do in performance monitoring? To ensure smooth and uninterrupted operation of LEV, to help detect any signs of poor performance of LEV, to avoid employees being exposed to hazardous chemicals, because they have the impression that LEV system is effective and it's not, right? To avoid unnecessary plant shutdown due to LEV system down, to avoid legal action and penalties due to violation of legal requirements. So here we have legal requirements. The FMA requirements are no longer there. It's now taken over by the use regulations. But just to highlight that under the FMA, you have the asbestos process, the lead regulations, and the mineral dust regulations that actually required testing. Previously, under asbestos and lead, you had to do monitoring, testing examination every 3 months. Under mineral dust, every 6 months. Now, under use regulations, the minimum is yearly. All right, minimum is yearly, and you have an inspection frequency previously weekly for asbestos and mineral dust. Now, under use regulation, minimum is monthly. But under use regulations, the inspection is done by the user, and the examination and testing frequency is done by hygiene technician 2. Under legal requirements for Clean Air Regulations 2014, you have various inspections under their technical guidance requirements, daily, monthly, weekly, annually by the user, and it's by the competent person in scrub operations or back filter operations. So for those systems where you have back filter operations or scrub operations, you are required to have a competent person registered under DOE. For LEV under use regulations, your monthly monitoring is done internally by end user or by employer. So you can assign maintenance, safety, or do a checklist. End user to do certain checklists, maintenance to do certain checklists. That is your inspection. But you have to follow the guidelines for inspection under the GKP guidelines for inspection of LEV systems. Here is extracted from the GKP guidelines. You can download these guidelines from GKP guidelines, and this guidelines on occupational safety and health for design, inspection, testing, and examination of LEV local exhaust ventilation system from the DOSH website. Okay, this is extracted from there. This is basically what you need to do. All right. Depending on what is your type of system. Basically, it is visual inspection. And you have your inspection item, what you need to inspect for, and an inspection indicator that explains why you are checking it. So it's actually a good guideline to follow. The guidelines do include things to be done by the hygiene technician 2, which you can opt to not include, just do what is the physical inspection or the visual inspection. Okay, it's all highlighted here. So you got to inspect the hood, observe how the employees work to see whether they are working, the location is good, look for obstructions, right? Look at the instruments being used, carry a smoke test if possible. You can also use string, paper or whatever to, if you don't have smoke, you don't have a smoke tube, right? So direction and size of the hoods, size, positioning relative to the contaminant. So these are all from these guidelines, right? So duct inspection, again, physical condition. You're going to see whether there are any damages, any corrosion, any damages, right? Internal, check for disconnecting ducts, right? On the inside, for systems where you carry dust, you want to see whether there's a piling out of dust or not, and then loose joints, because you have a lot of connections, a lot of joints, so you got to check whether there are any damages where leakages are caused. They're losing out flow rate to the system. Any abnormal sounds caused by inflow, outflow of air at duct joint. Okay. So condition of inspection panel, whether there's any inspection panel that can be opened easily, and condition of damper, and whether the damper is correct. For my experience, dampers in dusty systems sometimes are all jammed up with blockages. So
dampers should always be inspected on a regular basis. Air cleaners, same thing. Inspect outer surface of air cleaners, inspect inner surface, and do a hammer test and listen to see whether the dust has accumulation, right? All this can be found in the guidelines that I showed you just now, right? Air cleaner inspection. This is under DOE air pollution control systems, where they are required, the competent person are required to do this on a daily, weekly, Monday basis to ensure that the air cleaning system is in working order, right? Again, DOE requirements. So a lot of checking to be done by the competent person. Back filters, air cleaner or particulate scrubbers, air cleaning or particulate scrubber again, gaseous scrubbers. So a lot of checking. So this one, the competent person will have attended a 1-week course with EMAS, and they will know on this. Hold on. Is it? What's it? So this fan inspection. This is what you're required to do for your fan inspection. So casing, condition of inner casing, impellers. A lot of older model of fans do not have inspection panels, removable inspection panels. So you will have to do removal of the fan to look at. But if you have an inspection panel, there should be a regular inspection. Maintenance will have to do the schedule, and then to check whether the fan blades and the joints have any blockages or damages. Those any belt-driven fans, you got to check the belts on a regular basis, because belts can be damaged and mismatched, right? Sagging of belts and so on, and then tachometers. Okay. One, also examine the rotating direction of the fan. Examine fan rotating direction if the face and camera does not meet the inspection indicator. It must be specified as in design. Okay. Number 4, I want to highlight one thing. Okay. Somehow or other, I have done some systems where, you know, most of your factories have 3-phase wiring, right? And when I do the LEV testing, I find that the rotation is supposed to be clockwise, it goes anti-clockwise. It's probably due to the 3-phase wiring where it has been switched over, and then the fan is in the wrong direction. The fan is running wrong direction. There's still airflow, but airflow has been reduced. So do check the rotation direction of the system, right? On a regular basis, especially once you have done a maintenance on it. Condition of bearings. If there's a lot of noise, okay, it's usually the bearings. Make sure your greasing requirements is done. Leave it, then go in again. Okay, this is the example of inspection outlet. that you can look inside the fan, so you can remove it and have a look inside. Most of the newer fans, the bigger fans, will have this, and it's good to be able to see the inside without having to remove the ducting to look inside the fan. Then from here you can see whether there are blockages, damages, and so on. These are the performance monitoring instruments that we use. Okay, smoke tubes. We can use tissue. We can use example tissue, string, and so on to indicate the direction of airflow. Manometer is used by hygiene techs for measuring of static pressure or velocity pressure, together with pitot tubes, thermometers, hammer for testing. We're using sound test for thick wall ducting. Can be a wooden bamboo bar, where we listen to the what we call echo sound to see whether it is sort of an empty echo or non-empty echo. Tachometer is used for measuring fan speed, and motor speed, and anemometer is used for measuring air velocity. Tachometer, sometimes now we use stroboscope. We use it to measure fan speed against and this is compared against the design of the fan or of the motor. Examples of the various equipment used. Okay. And these are some of the performance monitoring equipment that is usually used by hygiene techs. Okay, U-tube manometer, incline manometer, digital manometer. McHelic is normally not used by hygiene techs, but installed into the system where you have air cleaning systems to show the static pressure of your air cleaners, tachometers, anemometers, smoke tubes, and hammers. Okay. Other performance monitoring instruments that are used usually in air pollution control systems required under DOE requirements for competent persons. And for annual testing by Hygiene Technician 2, these are the examples of what we encounter and we measure at the client's premises. Documentation control requirements. Documents required. Documents required. LEVs, approval letters from local authorities, from DOE, commissioning report, periodic data report, preventive maintenance records, annual LEV testing reports, training records, performance monitoring records. All this should be kept on, like I said earlier, and as long as the system is there, right? These are examples of written notification documents under DOE. And if you have submitted to DOE, they'll give you a letter saying that they have received your documents. This is an example, a sample of a LEV monthly inspection record, right? Where it's a very simple inspection record where you check hood, ducting, air cleaners, fans, check condition, who inspected, sign, what remarks, what remedial action. Again, this is a sample format. You can modify it for your own use. Air cleaners inspection record under DOE. You can redesign it to your own requirements, but generally follow the requirements of either the DOE guidelines or the JKP guidelines. Various examples and calibration. In our reports, we will have calibration certificates to show, right, that our equipment have been calibrated. These are examples of covers of the reports that we do for LEV. And you will find that the requirement is until the disposal, how the retention of the records is until the disposal of the LEV system, or it's been modified LEV, or to the next employer. So you've got to maintain the records for quite a long time. Requirements for record retention period at all times. All records should be made available during compliance audit by local authorities or external parties. Design and specific data made available for review when modification of existing LEV is needed. Okay. Also, for those in the safety line, you'll find that not many give me a moment, huh? Give me a moment. Okay, here I've extracted from the system, all right? From the DOSH website. Right, here from DOSH website, the legal cases for relevant to LEV, all right? And because a lot of people say, LEV, JKP won't kacau, right? Look at the number of cases that they have done. And they are the fines. So this I extracted from 2019 to 2025. And you can see, basically, they didn't do any testing of LEV. They were taken to court and they were fined. Okay, so this can be seen in also the Facebook page of JKP, and these are from all over Penang, Ipoh, Johor, and so on, all sorts of industries. Okay, so the fines, the highest fine so far. Okay, example here, KLK Premier Oil, 10,000 in Sabah. They didn't do monthly inspection, right? And most of 10,000 didn't do yearly inspection. Just a moment, just a moment. Yeah. The mic got a bit thing. Mic. Okay, I can't see my messages. So if you have any questions, you can open up your mic. You can open up your mic and ask questions because I can't see the messages now. Right. Okay, going back to the legal action taken by JKP. So they actually have been action taken by JKP for not doing monthly inspection, for not doing the yearly testing by Hygiene Tech 2, right? So there are quite a number of cases that can be seen in the Pendakwaan webpage of JKP, right? And which is JKP has been taking action on quite a regular basis. So if you get any notices from JKP, you should take action immediately to do testing. Here, another one, monthly inspection not done, 5,000. Okay. Yearly inspection not done, 5,000. A lot of it is not done on a yearly basis, but they do take action and we don't do on a monthly basis. I remember seeing one where they took action for not having a written, or not having an engineering, what do you call that? Engineering design, but I can't find it here. So please take note. Okay, thank you very much. That comes to almost the ending of my presentation. If you have any questions, you can come and contact us. And open for questions now. Any questions?
Hello. Yeah.
Yes, I can. Okay. Yes.
I got the one. I got a few chimney lah.
All right.
Some of my chimney, there is no pressure gauge, just because of they use mainly oil filter lah from the capturing hoods. So does it consider the pressure gauge many helix to be installed and to be measured by Hygiene Tech 2?
Okay. Is your system under DOE in the sense of that does your system require a competent person under EMAS?
Actually, the system doesn't compulsory to get the. It's not used as scrubber.
It's not a scrubber or a belt filter system.
It's the direct system, LAV2.
So you do not actually require a
pressure measurement.
A pressure gauge. That's more for your internal use, in the sense that if it has been designed by IR, in the design documents, they will have a air cleaning system where you have a range, static pressure range. By looking at the special static pressure range, example, let's say 2 to 6 inches, which means the system is within the range that is designed for. So some consultants, some manufacturers will actually install the magnetic meter there for you to easily see at the dust collect, at the cleaning,
filter and the filter lah.
at the air cleaning unit that is operating within range.
Okay.
But again, this is for the newer systems, and the older systems, a lot of them do not add this magnetic meter or pressure gauge. So it's entirely up to you if you're not covered under DOE requirements not to have it. But if you, as long as you are testing it on inspecting it on a monthly basis and testing it on a yearly basis by Hygiene Tech 2, you have fulfilled the legal requirements, and you should ensure that the system is being inspected monthly basis, that is in working order.
Okay.
And if you have a Hygiene Tech 2 testing it yearly, any shortcomings, remedial action should be taken according as per the recommendations of the Hygiene Tech 2.
Okay.
Okay.
Okay. Okay. Another questions. Actually I got a few that I use the filter with the pressure gauge lah. With the pressure gauge, the one all that you explained the dust collection lah. Okay, so I understand for that lah. But then about the monthly inspection for that one, but I did hear you said that needs that visual inspection together with capturing hood airflow velocity. Do you think is it compulsory or not, or just
you do not need?
No.
You do not actually need to. You can, if your company has a budget, you can buy the anemometer and do measurement. But basically, if you look at the guidelines, the LEV guidelines by DOSH, it's a visual inspection, right? And you can use smoke tube. You can use alternatives like a tissue paper, a piece of string, water mist moisturizer spray to see that the direction of the flow is going towards the hood. And then you can take photographs to show that you're doing this testing on a monthly basis and have a monthly record. And to me, this is, I'm used to it, so I use tissue or I use my hand. But I also use for demonstration to show the flow. The flow is being captured. I also use a mist generator to show that the flow is being done. So you can also use this type of
visual inspection.
Visual inspection, right?
Okay. Thanks.
Any questions? The chat seems to be unable to. Since I'm going to go in, so I'll take questions in from here. Any other questions? Ask any questions. Because I can't do any chats. Yeah. If there are no questions, I'll hand it to admin. Hold on. Admin. Close it off.